Today we're going to do inequalities involving absolute value. Don't forget what absolute value is asking for. Absolute value is how far is that number away from 0 on the number line, and you also have to remember that distance can't be negative. So here it says the inequality of absolute value of x is less than 3. And what that means is that the distance between x and 0 is less than 3. So you could have anything for x as long as it's not 3 or negative 3. Because what's the absolute value of negative 2? 2. Is 2 less than 3? Yes. And it works for the same thing. 2, absolute value of 2 is 2. 2 is less than 3. So the inequality of the absolute value of x is less than 3 means that x just cannot be more than 3 on either side of 0. The solution set, which we would write it as this, negative 3 is less than 0, or less than x, which is less than 3. So it's everything in between there, which is a compound inequality that we saw yesterday. Alright, write this. So this is what your homework's going to look like. It's going to say solve the inequality and graph it. They give you the inequality of the absolute value of m plus 2, which is less than 11. You got to figure out what makes this true. Well, when we're working with absolute value, you can have two possible answers. You can have a possible answer that was positive, and you can have an answer that would be negative. We've done problems like this before, but they were equations, not inequalities. So what we do is we separate them. Case 1, we treat m plus 2 as a non-negative or as positive. So we just work it out like it shows. So m plus 2 is less than 11. So we solve for m, and we find that m is less than 9. So that's all you got to do for case 1. Now for the second case, for case 2, you treat m plus 2 as its negative. Now it's done slightly different from the way we did equations. We just made the answer the one on the other side of the equal sign negative. But you can't necessarily do that, which I'm going to show you what they do, and then if you want to do the shortcut, that's fine. You have to treat m plus 2 as negative. So what I do is I write m plus 2 inside parentheses, and outside parentheses I make it negative. And I write exactly the same inequality, which is less than 11. Now, what I can do is I could distribute that negative sign out, or I could just do this. I can make it positive, which if I make this side positive, what I got to do? I've got to change the sign on the other side. So I'm going to make this negative 11. But when I do that, I have to change my sign. Okay? So this is what they're showing, in which really what they did was they just divided both sides by negative 1, which if it changes that sign, it's going to change this sign, and then dividing by a negative number, change your sign. So you can write it that way, or you can just do this. We write m plus 2, you change your sign, and you make your answer, you make the 11 negative. Okay, if you remember to do that. Some people don't. Some people have to write out this way and remember, okay, now I change my sign, I'll make that negative. Now I just solve for m, so I subtract 2 both sides. M is greater than negative 13. Now don't forget your case 1, which was m is less than 9. So you need to graph those two on the number line. So here's 9. Here's negative 13. It's an open circle for both. Hey, and m is less than 9, so it's going to the left. And m is greater than negative 13, so that's going to the right. So it's an intersection between these two numbers. So m can be any of those numbers from negative 13 to 9. Right? And this is a true statement. Alright, so you see this one, y minus 1 is the absolute value of less than negative 2. You have to do case 1 and case 2. You have to work it out. You have to solve for what y is going to be. The issue with this is that it says this is less than negative 2. Well, there's a problem. Can the absolute value ever be a negative number? No. This will never give you a negative number. Alright, so you can't do this one. So it would be an empty set. If you remember, it's just like when we did a problem like this. Okay, remember when we did absolute value equations? You have to do case 1, case 2, but would absolute value ever equal a negative number? No, so we said it didn't work. There was no solution to it. Okay, so your empty set would be your answer. All right, write this down. Now, the problems we were doing before was always where the absolute value was less than a number. Here, they're changing the sign. They're doing inequalities where the absolute value is greater than a number. And you can see from the example, the inequality absolute value of x is greater than 3 means that the distance between x and 0 is greater than 3. When it was less than, it was an intersection between one number and the other because x was between that distance. Here, x can be anything that's greater than 3. So x could be less than negative 3, or x could be greater than 3. So you have a union of one of these. Because you can see negative 4, the absolute value of negative 4 would be 4, which is greater than 3. And then you could use 4 on this side. 4 is greater than 3 as well. So it could be either that direction or this direction when you're working with the greater than symbol. All right? So that's the difference. When it's the greater than symbol, it looks like this. When it's the less than symbol, it's the union in between, or the intersection. Any questions? So write this down. So you're given this inequality here. The absolute value of 3n plus 6 is greater than or equal to 12. So again, you got to do case 1, case 2. You treat case 1 where 3n plus 6, what's on the inside of absolute value, is non-negative or if it's positive. So really all you do is rewrite it without the absolute value symbols. 3n plus 6 is greater than or equal to 12. Solve for n by subtracting 6 to both sides. And divide by 3. So n is greater than or equal to 2. And then you do case 2 where you treat what's inside the absolute value as negative. So I treat 3n plus 6 as negative, which I could write in parentheses and make it negative, or I can flip the sign, which it was greater than or equal to, so I make it less than or equal to, and make 12 negative. Don't forget to do that. If you don't change the sign, it's all going to be wrong. So make sure on case 2 you have to change the sign. Now I subtract 6. So 3n is less than or equal to negative 18. Divide by 3. N would be less than or equal to negative 6. So I need to graph those. I've got negative 6 here. I've got 2 here. Because don't forget, you have to have n is greater than or equal to 2 as well. So it's a closed circle at 2. Closed circle negative 6. But they're going opposite directions. N is less than negative 6, so it's going to the left. And n is greater than 2, so it's going to the right. And I can check my answers if I want to. All this means, this graph, means that n can be anything that's 2 or greater, or it could be anything that's negative 6 or less. And you can always check, plug in a number that's greater than 2, it's going to be a true statement. Plug in a number that's less than negative 6, it's going to be a true statement. Any questions about that? All right, write this one. Here you're given the inequality, absolute value of r minus 6 is greater than or equal to negative 5. Do you know something?
It's negative.
Okay, this is negative. Good. So,
It can't go to.
well, not necessarily. On the problem before, on the special case before, whatever it was less than the negative number. Remember that? It was like x, or x minus the absolute value is less than negative 2. Well, can absolute value ever be a negative number? Well, less than 2 is only going to be negative numbers, right? Because negative 3 and negative 4 and negative 10, they're all less than negative 2. So that's why it was an empty set, because it was always going to be a negative number, and you can't have a negative number. There's a difference here, because this says the absolute value of r minus 6 is greater than or equal to negative 5. Right? Absolute value, right, cannot be negative But think about greater than or equal to negative 5. Isn't that all, like, most of those numbers that's greater than or equal to negative 5, aren't they positive? Is 0 greater than or equal to negative 5? Is 1 greater than or equal to negative 5? Right? So the absolute value of r minus 6 is always going to be a positive number, right? It's always going to be greater than negative 5. So my answer isn't empty set for this one. Here, it's all numbers. Which if they wanted you to graph that, right, you just shade in the whole thing. And the way they write it is that r is a real number. But if you put all numbers, that's fine too. So don't get confused. Always look back to your notes if you see a negative number and see, okay, is it less than or is it greater than? If it's greater than, that's okay. But if it's less than, it's not. That's why it was empty set. Here's your homework assignment for today.